here we are in the Infomap surveys, river processing software. But before we do anything or look at anything, I really want to try and help us understand why we're here, what we're doing, who it's for, and where it all ends up. And I want to go back into the wonderful set of rivers that David James and I did down at Llandersil in Pentracut, an intricate connected catchment of 8 rivers. It's just coming in now, there we are. And it included the main river Teivi all the way up through there, through Llandersil, and all the way up, wandering it's all the way coming from right at the top there. And these 8 side streams, some of them are quite significant, some of them quite small. The little drain that they needed surveying, coming out of a playing field on the right and going out into the river there. How on earth do we start thinking about this? Well, the software was built up over a number of years based on the client's needs. Modelers, the sort of consulting engineers who have used us would be people like W.S. Atkins, they're now called Atkins Realis. Binney Black and Beach, they're now called Binney's. Mott McDonald's, JBA, Jeremy Ben Associates, Edenvale Young. These have been our major clients. And the main thing we've got to try and think about when we're surveying rivers is who is our client and who is our client's client. That's the first thing to think about. So part of all this complex understanding is we're trying to move away from topographic surveys where we're measuring fixed points or roads or fields and so on, and then we're trying to jump in rivers. And you can see that we've got an entirely different office here to work in. We're looking at rivers themselves, we're looking at the structures that the water has to pass through, and it could be anything. Let's go up further into Llandersil. There's the main bypass road there, but you're looking at really quite a considerable river here. The main thing we're thinking about as well is how do we get in this river safely? Can we get in? If we can get in, can we get out? So there's a huge number of health and safety aspects, but there's also the aspect of trying to keep abreast and keep on side the landowners of the land. You see, if we're working for, say, for example, Binney's, their clients would be Natural Resources Wales, mostly in North Wales, and the last thing they want is a couple of river surveyors blundering onto land without asking permission, then trying to get into a watercourse and making all sorts of errors and mistakes. So you can see there's a clearly defined methodology here of planning, certainly being given the contract by our clients. But the thing I'm trying to highlight here is that our clients' clients are our clients. And if you or I blunder into a river anywhere on these, you can see on this lovely river there, it doesn't matter where you are, what you're doing, unless you treat that land like your own home, there's going to be trouble. In other words, we're looking at the countryside code, shutting gates after you. Don't cross barbed wire fences by standing in the middle, stand at the post, so they're not going to rip the staples that hold the wire onto the post. Just simple things like that. And you say shutting the gates, and leaving the gates as you found them. And so it's all those critical aspects there. But once you've got in the river, you've got to be thinking about what are we looking at? How do we survey across a river? Now, I don't think in these photographs we've got any boating photographs. If you've gone, you should have gone through the whitewater training and so on, and the RYA Powerboat 2 boat handling course You know about getting a boat and moving a boat to a river. You know about the engine. You know about attaching it on the boat. You should also know about the fact that you never try and put fuel in the tank of an engine within 10 meters of a watercourse. So the best thing is to fill it up before you move it down to the watercourse. Simple things like that. So you've gone through all that training, and then we've got to be thinking in terms of what are the points we're looking at. And we could look at this photograph here. It's in the Llandersill Paddlers course, just downstream of the main central road. There's David and Mark. They're planning to try and take a section across here, and between where they are and the corner of the building. The Afon Tyweli is coming in just on the right there. But the point is, can you get in? You can see the bottom, and you can see it's quite deep. So David, in his dry suit, was then going to be getting in, and he could just about get across to parts of the rock area here. Then we could then take a section up the side of the building, do it remotely. It's quite a dangerous location. In fact, there were the fire brigade training was going on upstream. They were literally putting them into the river, throwing them, getting these guys and the gals there to jump in the river with their dry suits on and practice control as you come down a river in a dry suit. Leaning backwards, looking down river, legs up in front of you, and paddling gently backwards as if you were swimming. That gives you control. And they were coming down through this, so using it as a whitewater safety training exercise, and we were having to go and survey the jolly thing. So and here's another terrible bit. We never got in there, clearly. We had to assess that this was just too dangerous. We managed to get one of the ropes and put a lump hammer on it, and it was 6 meters deep. You could feel the bottom there. So all we could do was to get a reading this side and then take some remote readings to the rock cliff the other side and put on the drawing that was an assumption is whatever the level was, right down the bottom there. So you're thinking entirely differently compared to ordinary topographic survey work when you're surveying a bridge. Now, it might be that it's certainly that you need to be measuring the profile from the house wall side, coming down, and then taking the various points across, down into the deep water, through measuring the water level. You can see the bottom, it's relatively safe, but right in the middle was an enormous cleft that we couldn't cross, so we had to do some from this side, get the pole in on 4 or 5 meters, go back up over the bridge and come down, and then come down this side in order to survey it. Now, of course, you can appreciate that those points are wobbling about all over the place. They're not in a nice straight line. And so you're not having to survey the points of position as being so primarily important. It's the points for the elevations that you want to be surveying, and particularly the bridge abutment there, the start of the springing point of the arch, and taking a point there, taking a point in the top higher soffit point, and then down on the buttress the other side. You can see it's very, very deep in that part there. So we managed to find a methodology to actually survey that. If you were clever as well, if you were able, you could drop a weighted rope with a lump hammer in the bottom and on a tape as well, and simply measure all the way down to the point in the bottom. You've got to find ways of gathering data that you would never imagine in all your days as topographic surveyors that you would ever seek to achieve this. The whole point being that we're looking at the structure and the bank profile going up off to the right there, and we're surveying it for an elevation. The only way we can do that is to pick a left bank point, which might be up on the bank up there, and then we've got the right bank point on the other side. These can always be adjusted in the office, so it's best to try and take a point that safest for you to get to. And it's those points which are then used in the alignment. So you might have come down the bank and wandering about, waving about like this, getting in here, getting in the bottom, couple of points from the bridge. So you've got points that are generally connected with the structure, but they're certainly not in a straight line. And what the software is very good at is taking your left bank and right bank coded point and then straightening up between them as if it was against this bridge, this straight line of this bridge. So you end up then with all your points pulled downstream or upstream onto the alignment of the bridge that you're measuring, or the left and right bank point. And so you've got them all. It will then take the bridge and pull whatever points you've got on your structure, on your handrail, and it will also pull those points onto your imaginary but very important line between the LB, the left bank, and the right bank point. So you're not so much worried about position as how those points end up in elevation. And that's why it's really vital you get down into the archways of any of these structures that you're looking at, get inside, get your disto, getting a minimum distance so that you know that the left buttress vertical line there and the one that's in here, and you've got a measurement across between them, and it's a minimum distance, and that then gets coded in as you might say 8435 M from in the notes of the data logger. Or if you were taking a face measurement, sometimes it's better to do that, because if you've got a skewed structure inside going off at an angle, then the face measurement is equally important as the minimum inside width. The minimum inside width is also going to be narrower than the face width. So if you take a measurement with your disto very carefully, and you might have to, instead of measuring it from this side over to there, because the sun is on that buttress there, you won't see the disto. You might have to come all the way back over the bridge and get in here and measure back, and you'll then see your red dot over here and get your minimum inside distance, or in this case, well, after the face distance. So you might have 9364 F as the face, the sharp starts of the bridge there, face, and the minimum inside, which is going to be smaller, and they can then go into any of your BE, your bridge coded points, that will then get used in the software, in the live CAD, to actually help you draw. And so what you're going to do is you come back in. So if this is as we are looking downstream, we're going to use the left bank point, which is up out of sight there, and we've got a buttress. We'll have two readings there, a BE, a start straight there and going up to a BE, and we'll put the code, the suffix there, C, so it'll be BEC. That tells the software start of an arch. You'll go up to the top, BEC, and you'll come down to the end. So the next part of the structure is a straight, and that's BES. The software that can then draw that structure in position. That's absolutely vital. Once you've accepted that your left buttress is on, say, 6.35 meters from the left bank, you're going to then mathematically add your face distance, or your minimum. If it's going straight through like this, you can use your minimum inside width. But you want to then say, I'm accepting the start points of the buttress at 6.35. And then if you're adding on, say, 8 meters, because it's easy to think about, you're then going to have a 14.65 down this side, and it's going to fix the right hand line of the buttress, and that's going to be vertical. So you might need then to be playing around in live CAD to make sure the offset value is actually totaling from there over to here exactly 8.65 or whatever the reading is, and that's really critical. And once you've got that, you've got your codes for the curving bridge, and the software can draw it, and then it's going to fix that arch. I mean, you could, if you wanted to, use the right hand part of the arch as your as your anchor point for the bridge opening. And it doesn't matter if you then got to move the left hand or the right hand end of the arch, say 50 or even 100 mil. We're not worried about that. It's the actual elevational opening of the bridge and how the water gets through it, which is absolutely critical to the work we're undertaking. So I go on all about that simply because it's totally different from topographic survey. What is critical in all this are the bridge levels, the bed, the bed levels, the soffit levels of the arch. Ideally, you just want to get one, the side buttress, and then two elements to draw the curve, and coming down to here, a 3-point arch. That really helps the structural width calculations in as you get into the software and start doing all the editing. So it doesn't really matter where these points are, so long as they are generally on a line between the left and right bank openings. We could, though, if we went further down river on, say, for example, here we are, we're on, so the bed's quite high here, rivers, it's wider, so therefore it's looking lower. And if we want to measure across the watercourse to include certain points, we could actually go and say, well, we could be on the bank, the left bank here where the theodolite is there. But you might find that the gravel ridge that you're trying to survey as the highest point on the river at the crossing where you're measuring the section, you might there might be two counts. Count one is that you've come off the bank and you want to get show this in the cross section, but then you find as you come into the river that you're actually having to walk down, because although it might be deeper here, the controlling point of the river at this point, it might be a higher gravel ridge coming round and coming up then onto the left bank side. So there's every reason why you should move about to show the cross section, not as a precise line, but as certain key points that are going to help the modelling of the river. The other reason why you might want to not take get across the river at this point, you're going to come across and you're taking the edge of the water level there, so you've got gravel and water, then into the cobble on here, and you get to this point and you say, I can't go any further. The current is too great. You're in your chest waders or your dry suit, and you can get so far. You lean out as far as you can, and you get a point, say there. You can't cross at this point, but you can if you go downstream 100 yards, come down to a riffle, and then the gravel's higher, come round, and then come in from this side, do exactly the same, and you're going to get to here and lean out. And by that means, that's two reasons why you don't necessarily, you're going to survey on the line precisely. Always the left and the right bank points will pull the data onto the alignment, not only between the left and right bank, but if you've gone out into the fields onto the floodplain the other side, then and you're coming down, there's a bit of an embankment there, you don't have to be precisely on line. It's always the levels which are critical rather than the actual necessary the full final position of the points you're taking. Now, it's certainly absolutely essential on a big river like this that you have not only received your whitewater training, but you've also got your handling of the boat training, but you're also trying to read the river. Reading rivers is a skill that most people never have to worry about, because they're never going to go in it. They stand on the riverbank and they go, oh, it's nice, it's a nice lovely sight. In fact, this water is really quite deep here and it's flowing fast, and you can see what was happening coming over the weir here at the bottom end of Llandersil and Pentricurt. The water was in fact in semi-flood, and as I tried to come across from the building, I could get about 2 meters out. I was going to give it a try, but it was absolutely hopeless. You could feel the water was tugging. It's only just over ankle deep, but the water is going to flow fast over a weir. Oddly though, on some weirs you can be surveying and they're quite safe. It's because in normal flow you will have a sharp edge at the top of the weir, and the gravel builds up behind it. So you can actually, if you're not, instead of standing on the top of the weir, you'll find about a metre or two back, there's quite a high level of gravel, and it's actually quite safe. You just out of the flow, and if you know what you're doing, you've done it before, then you can walk safely on the back side of the weir. And again, the left and right bank points are going to pull the three elements of the weir which you're going to be surveying, and I'll mention this now because weirs are treated in a rather different way to a general channel, open channel cross section. On the weir you've got the three elements of the crest, surveyed as a WC code. You've got the element of just behind the crest of the hard bed, that's going to be an 8B code on the same number of the cross section, and you're going to try and get across the bottom and create another section at the bottom of the weir. It might be 10 or 20 meters down, but nevertheless it can still be utilized, and that is the LX code, the lower crossing. And then if you're able to, you're going to then measure a mini center line up that weir from I'll say 10 meters downstream to 10 meters upstream. And you're going to code this as LS. So you can have, and you'll start at the bottom, and in this case though, they're points that are going to be joined. So you do need to try and make the LS points as straight or centered to the river as possible. You have a point here, here, here. You'll feel from the bottom of the slope. You'll be in a dry suit. You're going to come up over to define the profile of the cross section through the weir, not across it, but through it, coming up onto the top, and then going off up slightly higher. And where are we? Let's see, we are coming on this one. So you can then take 3 or 4, 5 points along here. That data is then taken as you insert the import the data to the software. That's all handled as a special weir item. It recognized the WC code, and it's looking for the other bits and bobs as well. But I thought I'd show you that. That's how you survey a weir on this part of a river. Whilst we're looking at this massive structure here, which is just above the weir, you can actually see the boat that we're using, the small inflatable, just going out of sight through there. We actually had to put a rope across here. Roping on a river is quite a skilled job because you've got to tether it one side. It may be, say, to that little bit of tree there that's going to hold it safe. And then you've got to take it out, take the rope out with the boat and get across over here. Now, in this case, you'll soon find very quickly that if you've got the rope in the boat, you've tethered it one side, the moment you start to cross the river, and the rope is slack behind you, it will then very soon create a catenary effect, horizontal, so that you'll get so far, and the pressure of the river taking the rope won't be able to get any further. In this case, we had to take the rope. We was up on the left hand side there, and we then had to go all the way up to the get out onto the road bridge, carry the rope, although it was tethered to those two trees there, carry it all the way across, bring it down and tether it this side as low as possible, and then use that rope. It might have been slightly slack at the time because otherwise it was 3 or 4 meters too high, but it then meant you could safely start over this side. The surveyors, we came down here, point, left bank, point down there, water level. Get in the boat, and then you're holding on to the rope, and then you're taking points every 1-2 meters across this river here, and it starts to flow and take you down river a bit, but you're safe because you're held on that rope. And of course we'd had to plan then for what happens if the motor fails. Well, you're on a rope. That big weir is only about 50 meters below this bridge, but you're roped up, you're quite safe. You're doing 1 to 2 meter intervals across the bottom, coming out, maybe another check water level this side, and then coming up the bank. The rest of the structure is then surveyed remotely. So you're going to do, say, a remote reading to the top and a remote reading to the bottom or you might even take 4 points and have to work out what the diameter is. But if you only need, in this case, on this particular opening, the top center and the bottom center, and then you're going to call that a CT code, a culvert, because water would flow through it at peak flow. I can't imagine having flow that high on a river, but I think it has been up that high. And you'd give it a diameter. So you could call it a CT code, have the invert level there, and then give it a positive diameter that gets drawn on the structure. As before, you need to come up with a BE code from the bottom, maybe below the surface with a pole, but then remotely ping it, the springing point, top center of arch, and the right. But that can all be done remotely. You're also, in this case, there was the old railway arch is up on the right hand side, and so this was the upstream face. You're going to treat you've got points coming across, ground levels across here, and then you're not going to be worried about the buttress. That is architectural detail that does not affect the flow. If it does affect the flow, you can survey it. You're not worried about architectural details on bridges. You're only worried about the road deck. You're worried about the parapet. If there was a handrail, you're worried about that, and the profile across the river. It's those major elements which you're worried about. And I say you could then treat this as a second BE string opening, so that of course in the software you're going to have a BES, BES, BEC, BEC down the bottom to a BEN. That's important. So you can have you can only have one BE string, but it can be made up of separate BE elements, so that you have another, start another BES code here, or BE code, BE, BEC, BEC, BES, and down the bottom to the ground level there. You'll take your minimum inside width, put that in the notes of any one of the BE codes, and you've got that included. By that means, and then that your profile is probably then going to go up through it was up onto the embankment. This was a massive structure, and you just got to plod away and get all the points. So there's your bridge structure there. Interestingly, you can see the bridge, and I couldn't see it in the other photograph. So you're going to have your BEC code at the top, BES. You're then going to go back one with the BES and down with the BES. These offset buttresses or any change in the structure is vital to ensure that you've got all those details. And as always, if you're not sure, survey it. By the time you come back, if you haven't surveyed it, it's too late to go back. But as I say, this profile then came across here, up onto this lower field here, the FE code for the fence, up the embankment, onto the old railway line, and I think we had an RB up there, but again it's all HB codes generally, and then into the hill going up the other side. We're describing the whole profile of the river valley that could reasonably be flooded by water in this particular area here. Whilst we're talking about structures, on the Severn Vyrnwy, or the River Severn survey, there was a bridge that was an old railway bridge. You can see it here. It's going, and it was converted into tarmac road. It was going into, I think, Criggion quarries. So it was an industrial line. But here the bridge has been repurposed for a road. But that's our interest is, how does the River Severn get through it? And you can see the steel girders here with these cross braces and so on. Well, David and his merry lads managed to scan this structure, and then Justin extracted in their software and getting it into here. Here's the structure here. And there was something like 109 openings, because in order to convey the real shape of the structure, we had to show it like this. These were concrete supports here, and a steel work was all in there. Here's your upper steelwork. Here's that line there is your parapet line, which in effect is that line of the top of the steelwork there. The road deck in red was there, and so they managed to get all this stuff here, and no one else had ever got this before. No one else had ever managed to confine or define the structural openings of all this here. And Justin must have spent a day or two sorting this out. But it was vital for the client to have this data. So that's how we surveyed that. Even the handrail at the on that point there, which equaled the, you can see the slight opening of the handrails there. All that means something. But the fact was the modelers could then see where were the openings, and the parapet, I think this line here is the Tar Macadam parapet here, that red line. So that was defining how the water would have to get over there, and all these openings then ended up in a structure width table. We never seen anything like it. So this was a very different project to normal, but they rightly judged that these were structural openings that water could and should pass through, and therefore the modelers needed to know it. I've just run a bit out of sight now the structure widths software, and that's how the structure came out. If I go to the top right here, opening 130, 132 with all the tables there. But here's the bridge structure here, and you can normally, so that opening was shown like that. The next opening gets defined like that, and the next biggest opening in terms of the bed profile is like that. But those are complete openings. But they're also complete openings, these little ones here. So the software will work extraordinarily well, even up to the full amount of those sort of openings on a bridge. And all you need to do as a river surveyor is decide what is important. If we go back to the photographs for the other river, I can find it. Shut that down. Yeah, here we are. These are flood openings. If there were pipes coming in on the side of the river, where, say, road drainage or land drainage or whatever, those are always CT codes. Anything to do with the structure where water is going to pass through is either a BE code for the arch or the opening, or a CT code for the culvert itself. Whilst we're looking at bridge structures, the other thing I want to show to you is the issue of a skewed structure. Now you can see on this here that the river, on this side stream to the Tivy, that the river is coming through underneath a road bridge, and you can see the skew angle that is being obtained here. This, you might be able to see it better on this one. The issue here is that skew angle you need to measure along the face of the structure, not only the structure information, but also the bed profile along the face of the structure. If it's not a huge skew angle, you can actually keep the bed profile perpendicular across the river, still survey the points, and then those slightly skewed angle points will be brought up onto the straight line between the left and right bank points. In this case, though, this is a considerable skew, and what you've got to deal with then is doing it along the face, the bed profile along the face, just as you would as normal. But it's critical that you then get in underneath with your disto and then get the minimum cross river perpendicular to the watercourse distance between this buttress here and the one that's just on the left. We can't quite see it, I don't think. Well, what else have we got here? Oh, maybe that's a lot better. There we go. Let's go back to this one. There are some cases where the skew is so enormous that, in fact, there isn't a part of this left-hand buttress would actually not be perpendicular. Well, it would be perpendicular to the river, but you can't measure straight across to the right-hand buttress because it's too far down the river or too far up the river. But in this case, you need to get inside here and measure from the upstream end of this part of the buttress across to probably somewhere in this area here, and again measure the measure the correct perpendicular inside minimum distance. But you would also want to here, as I said earlier on, measure from the face start of this buttress, which is slightly smooth there, across to the sharp end of the other buttress, which is on the right hand end. We had it just now. I want to show you that. Yeah, that will be in that area in there, and that will be the face measurement. So you need two measurements on this bridge, the longer structure face, the actually face to face edge, which would then have a suffix of the letter F, and the minimum inside distance width, which would have the suffix of a letter M. And those can go, or ought to go, on any of the 2 points on the bridge structure BE opening. But it's critical that you get this stuff here, and particularly the minimum inside one, because we've got in the live CAD, you'll discover when you do it, if you use that minimum inside distance, you can then calculate the skew angle of the structure that is needed to ensure that when the skew angle, it might be in the area of 30-40 degrees on this, it's difficult to measure off OS maps. You can do it, but if you've got your minimum inside distance width, we can calculate and copy the calculated skew angle of the bridge and put it into the correct angle code on the header of the bridge structure. And that will then, when it gets exported, when it gets drawn, it will draw it as you are looking at it now, but in effect the skew removed, so you've got it's a narrower cross section than it actually is, and so that's how it gets drawn. But it would also be exported skewed and foreshortened in all the export modules that we've got as well. So that's why it's important to recognize the skew on site, treat it as a skewed bridge, take these minimum inside distance, the minimum and the face width carefully, so that when it gets drawn, it all gets shown properly. Whilst we're down this part of the Teivi, we came across the old rail bridge buttresses. They were cast iron rings filled with concrete, and there they are there. So there's no bridge there. The abutment's on the left, there was a similar one on the right, and in the middle were left because for whatever reason the railway wreckers couldn't retrieve the steelwork here. They got rid of the bridge, but this is in there, so I would still treat this as a bridge opening, and you could use BE code for the buttress over that side. You could also use a BE code up the side of this and across the top. So although there is no road deck, you'd have to deal with that back in the office. But again, it's something if it's there, you think you need to survey it, then jolly well do. Otherwise, it's too late. But then, here's some nice shots of the boat in on the side here. Where the river wasn't running fast, we could use a tall pole and just simply hold the boat in the current and do it like that. Again, it doesn't matter if you wander up and down across the river. It's all pulled onto the left and right bank point. Then as we came up, coming back up into the middle of Llandersill and the bridges here, we could then go further up, and up here there is somewhere, here's this little suspension bridge. Nice and easy to survey. We weren't in this case worried about the openings because these vertical bars are going to make no difference to the flow of the river. But you would still come from the field into the left upper bank, down the rock armour, code it rock armour, down into the water, code it for gravel or the cobble it probably was. You're then going to use a BE code to go up the inside of the first stanchion there, up to the underside and come across under the soffit here. The deck level is that little bit there, and in effect the handrail would come right over the top. Fairly simple, a lovely little bridge, but fairly simple to survey. The other thing that river surveyors often do is use the use of resection techniques to position theodolites where they're in trees, and all you can do is actually go out on into the flat land beyond and put in 1, 2 or 3 control pins, mark them as something, call them the control pin 1. So when you set up your theodolite, you can then take the first 1 or 2 readings, which are your resection points. When you get back into NForce, you can right click, and the coordinates of, if you've used GPS out there, the coordinates of this point, notice there's no pin underneath it there, you don't need control pegs under there. It's the center point of that theodolite is automatically worked out for position and level, and then you then go on happily and measure across your section through the woods. It's one of the best things you can do. Get your theodolite where it needs to be, and then look out beyond, out to the open trees area, wherever it might be, through the brush, through the other side, and you can survey quite safely and very quickly open channel sections. If, for example, the trees were so bad or the access was so bad, you might try and get a setup that was between 2 sections, so you can see 2 sections or even 3 sections from one setup. If you have to traverse down, we've often had theodolites set up in rivers where the access is so appalling. Don't be afraid to use a resection for the top end of a traverse down 2 or 3 legs and come out onto another resect point and work out the travels between them. And those techniques are very, very effective in river surveys. You wouldn't want to be trying to put pegs in the ground and doing traverse surveys as you would do on land, because it's so much quicker and easier down through this very difficult open woodland. Although you can see a fair bit, you're then going to come through all sorts of areas where we're actually outside in the field there, and probably we've got 1 or 2 pins. But the ease of the good thing about the resection pin is that you critically have to double check your pole height, because you haven't got a height of instrument under the theodolite necessarily. You might have a point there and also 2 other points as a check, but if you're in this area here and you're looking out, you've only got your height of instrument at this point, which is notional. But more importantly, when you're looking out at your pole heights, it looks like the GPS receiver is just out there in the distance. There it is there. It's on a point, and that pole height is critical. You've got a second point there, pole height critical. You're using then the levels and 3D points of those pins to resect this here, but you don't need a height of instrument. But you do, of course, need the height of your pole coming across. That's the only useful thing to think about, but it's very different from doing topographic surveys. You may well also so you've got trees in the way, goodness knows what else. You can only see certain points from a control point upstream and downstream. So you might have resected to a point here, say for example. But you can't get down below the bridge. But what you can see, you can throw another survey station down to the gravel in the distance. So you've got in effect a little 2-point traverse. So you can get everything on this side of the bridge, get your theodolite, walk down through and set it up down there, angle back to this point. So you will need to put a temporary pin in the ground here underneath this point, and then you've got a 1-point setup on a control pin down there with an RO back up to here. But also you can use the offset for the pole. If you've got your pole set there and you can't see the end of the parapet, but you can take an offset reading here. Your accuracy at the end of the parapet is not too much of a problem, because as we've so often said, everything gets pulled up onto the left and right bank points. So you will have your raw site survey data in Enforce or whatever processing system you're using will be the original data. But when it comes into a DAT file, it's all straight line stuff. And when you then plot your DAT file, you can plot a straight line, so that all the points, as you will see in the software videos, you can do that there. But again, that's another technique, offset, and you might not even see the left top of bank. But as long as you can get an offset to the right, you're looking back at the instrument here, then you get an offset right. So you have HB 405 and an offset right of 2.13 or something. That's the way you would then gain behind the tree the left top of bank. If it's not quite accurate, it doesn't matter. What is more accurate, effective, and important is that the straight line points that get brought up onto your cross section are valid points, and that they're pretty okay when you come to take your utilize your left buttress of any arch, have your minimum inside width, and then adjust the right hand button. And you can do that for both of them. You could do it from right to left or left to right, but it's no point in using a vertical pole which may not be vertical to take that point. You can do your best, but you might find you can't quite get on the position in behind this chunk of rock here, the buttress there, central buttress of the bridge. You get in as close as you can. It's the levels which are critical. So you can ping your bottom level there. You can try and get the level of the right hand side of the arch, but then you found that your pole may be leaning a bit like from the bottom left of that there up to the top right. Doesn't matter, as long as you've got your level and you've got a reasonable point here, you can then use that as your fixed start area there, and then adjust in LiveCAD the distance across the offset to get to this point, which might be a bit hidden. All sorts of techniques are needed to and used to get this sometimes quite difficult to access survey information. So I hope you're getting the feeling that you need to move away from precise positioning concepts of topographic survey, which are perfectly reasonable and are absolutely essential in that area. What we're trying to do here, we are often struggling in rivers, struggling with weather, struggling with the flow, can't see the bottom, and all those elements. You might have an angry farmer on one side or stock in the field, any number of factors you've never had to come across before. Means you've got to use all these techniques and aspects to try and get a reasonable cross section. Don't forget, these are snapshots. The next flood is going to be slightly different. No one is ever going to go back and check your readings unless it's on, say, a good fixed point on a nice open part of a structure. That might be checked. Say, for example, if you needed to go back, say, for example, look, you've done this bridge before, you know it's good and it's okay. 5 years later, the client or the Environment Agency or Natural Resources Wales come back to you and say, could you please check the bed level, because we think the river's brought a lot of rock down, and this area here from the underside of the bridge down to the bed has got choked up, and instead of being down there, it's now up there. What we can do then, we can take a couple of checkpoints on the bridge, resurvey the bed profile correctly, and then come back into the LiveCAD here. Let it come in a minute. I'll move that out of the way. Here we go. If I browse back to here, I'm back in Pentracook. Here we go. We can come back into any of the sections here. We'll try and find a structure, and let's move that out of the way. And what we should be finding then, it's coming in now. We'll find a bridge opening. Let's go to Here we are on number 1 and 2. Shut that out of the way. And we'll come on, we'll use this good old structure again. Now in this case, we want to redo, do you know what, I think I'm going to go up to the upper area where we got some better structures. Oh, that's our little footbridge, fisherman's footbridge. I'm going to go into this one here, where I think we've probably got some better illustrative structures that we can use. Yeah. If we wanted to resurvey this, yeah, we've got the top left of the parapet there, which is shown at this point here, that one there. So we'd resurvey the bed. Under the new, so you've got the old survey data. You can have a cut and paste. You want to keep the old bridge data in this part of the file here. There we go. Keep that in there. You want to insert then the new data from another DAT file, and you're then going to replace this. And when you get to here, then you want to simply use adjust data and the bed profile to structure, which then asks you for the common lock point, which might be the top left of the parapet. I won't do it now. And then it will pull the bed profile across between, in effect, matching the two surveys, and it will come across like that. Again, that's another example of the situation where you're dealing with all this stuff and you're doing your best, struggling through all sorts of muck and mud to measure the profile at a structure where you don't want to resurvey the structure, especially a complicated one. That's again another tool that we can use. Okay, probably the near final thing I want to say now is that the modelers that you are providing your modeling data to, and you'll go into this in the rest of the training videos, they will 99.999% of the time, they will never ever go there. You are the eyes and the ears for the modelers and your clients. So therefore it's critical that you try and get as much information, especially photographic information, even video information, if you think that you cannot usefully inform the modeler who will be looking at all these photographs. There we are, 17UL, the R, that's an OF coded pipe coming in there, and then we're looking at the central one, C1, C2, we've got most of the buttress there, and then the upstream view. These views are absolutely critical. The modelers are going to import your exported modeling data from this software and put it up in Flood Modeler or HECRAS or TwoFlow or whatever, along with these photographs. And these photographs are critical so that you're not only showing the watercourse under the structure. This was number 20. Let's go back down to, nice enough little footbridge to somebody's property there. There we are, number C1. That's the upstream, and that's the left floodplain, and here there's probably the right floodplain. There we are. And all those four photographs mean a huge amount to the modelers because they're looking at the river, not only the flow, but they're particularly looking at what is causing the river to slow down, the roughness of the bed and the banks, and therefore even the gravel in the far distance, the bits of rocks here, and the side buttresses, and then looking on the left other side, the grass. Everything that you see there and have laboriously coded, and which is then going to go through into the Manning's values. They're going to be exported in most of the software. It doesn't go out in HECRAS, but it goes out in Flood Modeler and TwoFlow. They're ready to run Manning's values, and they're usually represented by a figure of, say, 0.1 or 0.35, something like that. We don't understand exactly what the values are, but those are the official river modeling Manning's values, and they're sort of a percentage, a fraction like that. And if so, you might want to put on for a road might be 0.5 or 0.05 or something like that. Every point has a reading, so in the moment they put it into their modeling system, they're looking at what you've taken on site, and that's why it's so important to try and get this stuff right. Don't forget though, of course, the Manning's values on any point act as the Manning's values for the next point. So if you're coming down if you're coming off this left bank here, you've got tarmac. That's going to be a tarmac code. Then you're coming onto the left bank. You've got LB, say 501 or 504. LB, and you come to this point of the rock here, LB 504, and it's going to be rock. You could put RA for rock armor. You won't have anything for the vegetation because there's nothing there. So you'd have LB 501, 504, RA, and down the bottom you've got the cobble. You change it at the bottom because you're working from left to right, and you change that to you'd have a water level, a WL code there. You don't need a code on surface or vegetation code there. As you bottom of that point is then going to be a CO and then NO. You can just leave it as CO. The import software says this is just, there's a point there that it's got no and nothing after it, therefore I'll automatically insert NO for you. So you can come down off there and across the bottom, so that when you get to the last point there, the bottom of the bed, that although it's in gravel or cobble, you've then got your rock armor. RA starts at the bottom and it comes up over the top like that. So you're coding for the next the point between where you are to the next point you're going to take. That's the way you get the codes in. And of course, if you're working from right to left, you've got to remember which direction it's going in as well. There you go.